So it is my pleasure to introduce, first of all, Dr. Anthony Watts.
Good morning, everyone. A couple of years ago, would never have expected to have been here because, quite literally, my presence here is by accident, and I'll explain that in a moment. First, I got to figure out the computer here. Here we go. I'm here because I was interested in paint. That's really the thing. And one of my first projects in college was to put together a Stevenson screen, which housed a temperature sensor. I did that for the college, and I remember the paint coming off on my hands, and it's all chalky and white, and I went to my professor, and I said, "What is this? This is awful, this paint. Can I repaint this thing? Because it's just awful." And he says, no, don't touch it. That's special paint. That's whitewash, and because it has a specific infrared character. You don't want to mess with it. Oh, all right, I'll leave it alone. Put that in my mind. 30 years later, I found some time in my hands, and I thought, I want to check out and see what happens, because I had heard that they had changed the paint. In 1979, the Weather Service had changed from whitewash being the specification, which was natural, of course, because the Stevenson screen was invented in 1890, and back then, whitewash was all they had. But now they'd switched it to latex, and I wondered, was there a difference in the way that the paint made the temperature change inside the shelter? So I started looking at shelters to see, first of all, if they had been repainted. And the very first one I visited in my town at Chico State University had an oddity. It had been converted to automation, and amazingly, the temperature sensor was just inches from the radio electronics. And I thought to myself, who does this? Who puts a temperature sensor next to electronics? Electronics makes heat. It was a fluke, I thought. So I moved on to the next station to take a look. This was Heartland, California. Found out, perfectly sighted, everything looked normal. And I thought, really, the first one I saw was a fluke. And then I found the third one. This is in Marysville, California. And this is when I started getting alarm bells. I looked at this and I said, this is a climate monitoring station. We've got a thing called an MMTS, which is the new style electronic sensor, right in the middle of a parking lot. And I could stand there right next to that sensor, and those buildings right behind it are cell phone buildings. They've got electronics in them. And I could feel the air conditioning blowing from those buildings. The warm waste heat from those air conditioner units was circulating around that sensor. And I said to myself, 2 out of 3 places now I've visited have really bizarre problems associated with warmer temperatures and biases. How can this be? Started plotting the data, and sure enough, Heartland, the good station, was cooler than Marysville. So I started looking around more. I found one at the National Weather Service office in Monterey, California. It's on cinder block and gravel next to a parking lot. I found one at the agricultural office in Woodland, California. It's a co-op station right on a parking lot, measuring the temperature of a parking lot. So I came to the realization after doing some research that no database of quality metadata describing what kind of potential biases might be there for thermometers existed. And I started talking with Dr. Roger Pielke at the University of Colorado. And after talking with him, decided we need to document this and put together a website called surfacestations.org. It's got a main portal and a gallery that shows all of the different stations in the USHCN, in the U.S. Historical Climatological Network. Here's some of the examples of things we found so far. We found lots of places where things are sited directly over things that would normally be pretty warm. Parking lot and volcanic cinder, gravel. This guy has rubber mats down, black rubber mats, because he doesn't want to get his feet dirty when he goes out to measure the temperature. We've got volcanic cinder and gravel at a water treatment plant and the sensor right over it. This is volcanic cinder, large chunks of volcanic cinder at Wairika, California at the Forest Service office. Wood chips. I never thought wood chips would be really warm until I walked on them and then discovered that they were actually warmer than asphalt. And some infrared photos I took verified that. Found this one at Lake Spalding, California. This is the sensor up on the post there, or on the tower. And as you can see underneath there, there's a boat. We think that might be there in case of catastrophic sea level rise. This is what the station used to be. This is what it is now. That's what it used to be. A cooler environment, wouldn't you think? The reason they moved it is because of vandalism. And I discovered something else. In the 30 years I'd been involved in meteorology on air as a television meteorologist, I was always pretty much accepting of data as data. Where it's measured is going to be measured in a good place. I never expected to find that we would be measuring climate at sewage treatment plants. Yet, this is a truth that I discovered through this project. This is Midland, Michigan, the Stevenson screen, right there. You notice that object to the right? That is a vent. That's an underground tank where they process sewage. Now, during the winter, the curator says the snow does not stick to the grass there. And it's because the tank is warmer and because there's warm air coming out of that vent. Great place to measure climate, don't you think? We found lots of other places just like it. This one in Urbana, Ohio. You notice the refrigeration unit to the left there? I asked about that. What's that for? And the curator said, well, when the guys are out there working on the pumps in the plant effluent system there or whatever, it gets so hot out there that we turn on this refrigeration unit to keep them cool while they work. Yet we measure climate there. Here we have one next to an incinerator and just a few feet from an open sewage dump. The MMTS has mold all over it. It darkens its albedo. At Cape Canaveral, Florida, or near it, Titusville, Florida, the sewage treatment plant. Yes, it has a climate station of record right above the tank. Here's what a sewage treatment plant looks like in infrared. You can see, this is during the wintertime. I photographed this in Oregon. It was 32 degrees outside. Basically, you can see the steam rising off the tanks. And in infrared, the tanks are glowing, and the temperature of the tanks themselves, measured by infrared, is 13 degrees over ambient. Found lots of other places where just placing them next to buildings, obviously there's heat being radiated off of those. This is at a gentleman's home who's an observer in Livermore, California. The swimming pool's in the foreground, his house is in the background. I pointed out to him that he might need to check his insulation on his house because you can see a lot of his heat from his home is radiating straight out. Perry, Oklahoma, the fire station, that heat is radiating off the sunlit wall. And here, next to a small piece of sidewalk, the sidewalk was initially placed there. The Stevenson screen used to be at the very end of the sidewalk. They did that again so they don't get their feet dirty. You can see this is right after a rain. There's still plenty of heat radiating off that sidewalk. We found lots of instances of Stevenson screens over concrete pads. This one is only a couple of feet from an entrance to Highway 101 in California. We find them at airports, right next to the tarmac. This one here, they had trouble with the post, so they simply strapped it to the deck. Science. Air conditioning, lots of vents there pushing heat toward the MMTS, and of course it's just a foot or so from the building. Do you think that might be warmer? Here's one over cinder block again, or cinder gravel, just a couple of feet from the building. This is in the middle of Nebraska, the Great Plains. You can look off in the distance and see all that open space. Where do they put the sensor? Right next to the building. And there's a reason for it. Notice the path there, right next to the telephone pole? I'll tell you about that in a second. We found them on rooftops. There it is, right on top of the building. Lots of other ones on rooftops. This one here is just a few feet from an air conditioning vent. You can see it to the lower left of it. This one here in Santa Rosa, California was quite a surprise for me. This is at the newspaper office down there of the Press Democrat. The sensor is right in the middle of the building downtown. Certainly a warmer place. And it's not just in the West. We find them in Maine, and we find them in Maryland. In Baltimore, Maryland, this station was so bad in terms of records that it was producing that the National Weather Service decided to close it in 1999. This is where it's located in downtown. They did a study and put it in their own training manual about what not to do. And they showed here that this Baltimore rooftop station had maximas of over 100 degrees, 13 times when no other surrounding stations did. Reason to close it. Yet this remains a part of our climate record. The data has not been removed. You ever watch the Beverly Hillbillies? If people know that show, this is what I call Granny's weather station. Cortland, New York, at the newspaper there. They apparently couldn't afford a Stevenson screen, so they made one. This is what it looks like. Literally, words fail me. And worse than that, the internal sensor is even missing a few plates. You can see the screws on top there. It's missing a few of the top plates. Where they came up with this, I don't know, but it's part of the climate record. We find maintenance to be an issue all throughout the United States. Here's a badly maintained one. The Stevenson screen's falling apart, and there's all sorts of brown material all over the MMTS. We find them next to air conditioners. This one here at the State Hospital in Napa is just about 9.5 feet away from that air conditioner there. This photo here tells another truth that we discovered in this project. Now you notice the MMTS, which is in the foreground in the shade there, and then the Stevenson screen is off in the distance over in the field. The MMTS, the new unit, replaced the Stevenson screen. It had the cable, however. The Stevenson screen and the mercury thermometer was the original wireless weather station. You could put it anywhere, but the new one has to be cabled to a sensor display that's inside the building. The problem is that the person responsible for installing this upgrade is given a pickaxe and a shovel and an afternoon to do so. They can't get past obstructions like a parking lot or a driveway or a sidewalk. And so the sensor ends up getting closer to the buildings. If this had been a conversion done all in 1 year, it would have shown up in the record. But it was started in 1985 and it continues today. Every year they convert a few of these, and so it's been a very, very gradual change in the signal, undetected, because they're getting closer to the buildings and to air conditioners and cinder rock and asphalt. This one here, in Detroit Lakes, Michigan, the Stevenson screen actually used to be further out. But you notice there's the reeds there, that's a little bit of a swampland. The story about this is that they moved the Stevenson screen and took the mercury thermometers out and put in the MMTS there because they were worried about someone breaking the mercury thermometer in the middle of the swampy area there and having a hazmat for wetlands problem. I kid you not. Even the Weather Service can't get it right. The Weather Service in Eureka, their Stevenson screen is in the shade. Makes it a little cooler, but is that really the best way to measure climate? This one here has convenient parking, and it's got a burn barrel next to it, you might note there. And of course, this one here, the one that just shocked us all from people that should know better at a university. This is the University of Tucson in Arizona. This is the weather station operated by their meteorology department. It is an official climate station of record. It is in the middle of a parking lot. It also happens to have the sharpest trend of any station in the United States. Here's one we found in Lampasas, Texas, downtown at the radio station right next to the Ace Hardware store parking lot. Interesting thing about that, not only is it warmer, as you can see in the record here, the temperature zoomed when they moved it there recently, but it gets adjusted. This is from NASA GIS. They adjust the temperature going through their homogenization process, and when you compare the two, you find that, by golly, the past gets cooler, even though the present is incredibly warm. The adjustment itself makes the slope even steeper. And this isn't an isolated example. Here's one at an industrial complex, a mine in Miami, Arizona. The MMTS is near a building. It's a south-facing wall. Pretty warm there. Lots of black gravel around. And you look at it from space or from an aerial shot and you see, wait, the whole area is surrounded by dark albedo gravel. Seems to me it would be a very warm place. And the temperature record tells us that. You can see the spike there when it was moved there and the gravel put down. Warmer. But then it gets adjusted again. And there's the comparison. Adjustments of the temperature record make the slope even steeper. And it's not just people like NASA GIS doing this. NOAA does a series of adjustments themselves. And these adjustments actually add to the record. This is a composite of all the adjustments that NCDC and NOAA does to the data set up to the year 2000. You can see it's added almost a half a degree by their own adjustment methodology. This is their own published graph. I didn't make this. So we decided we were going to evaluate these based on a criteria, and we borrowed a criteria from the Climate Reference Network. It was a simple 1 to 5 rating system based on how they chose sites for the new Climate Reference Network. We borrowed that and applied it to the existing network. It's based on distances, and we just simply apply a rating 1 to 5. There are 1,221 Climate Reference Network stations in the United States. We surveyed so far 78% of them. And you can see in the map there where it's colored in, lots of orange and red there. This is the results based on applying a rating based on distance to each one of these stations. You can see that the lion's share, CRN4, 60% of the network, has a potential error of 2 degrees C or more. This is based on NOAA's and CDC's own assessment of how a site should look and their estimates of temperature error. 8% is a CRN5, which has a error of 5 degrees centigrade or greater. And only a small percentage are CRN1 and 2. A very tiny percentage are CRN1, and a good percentage of those are actually at airports. And the only reason those are the good ones is because they got to be put out with the new ASOS system out in the middle of a field. But even those aren't the best places. Airports tend to be pretty warm. We've done some preliminary analysis of the data, and here's what we've got. This is raw data. We have not done any adjustment of this. This is our CRN rating compared to the actual data from NOAA. Now, there's 3 data sets, something called raw, TOBS, which is based on time of observation, and then something called FileNet, which has to do with a filling-in algorithm. And as you can see, the best station, 1, is cooler than the worst stations, 5. We have some differences here, but a lot of these have to do with regional siting differences, and we're working on a detrending algorithm to help us with that. But something really interesting, concrete, asphalt, brickwork, things of this nature, human habitation tends to keep heat at night. It also tends to elevate humidity at night because we irrigate lawns and things of that nature. And so we would expect T-min to be affected the most. And the most dramatic results are, in fact, in T-min. There's raw compared to CRN1 versus CRN5. A signature is there. Siting matters. It's that simple. Here's our conclusions. The majority of stations have the new sensor installed. And because of the new sensor, it forced the stations closer to the buildings than the original Stevenson screen network. The majority of stations have errors larger than 1. Some are 2 degrees C or more. Wastewater treatment plants figure in greatly. We don't know why those are used in the temperature record, but we know them to be heat islands. There's quality control lacking in the US HCN. Only 10% of stations meet the basic 100-foot rule. And there's microsite biases that are not being accounted for by NOAA or NASA in their data procedures. And sometimes they actually make them worse, as we've seen in their own adjustments. The magnitude of errors in the United States Historical Climatological Network may be greater than the AGW signal itself. And we'll have questions with the panel later. Thank you.